Somewhere above you right now, an ordinary yellow star is doing the one thing it has done every day since it formed. It converts its own mass into light and heat and fires the result in every direction, including directly at you. It is, in the most literal sense, already aging you. Slowly. The process never stops, and compared to everything else floating around out there in the galaxy, our star is, honestly, the boring option. None of what follows is a warning. Nothing on this list is coming for anyone watching this on any timeline that matters to a single human life. Think of it instead as a countdown of the documented, physically real ways a star can end a planet, ranked from the mechanism. Zero warning at all. There are at least 6 of them on record. 2 were only confirmed in the last 15 years, and the evidence for both had been sitting quietly in tree rings and orbital simulations the entire time, waiting for someone to actually look. We will start with the slowest one, the one that is, unfortunately, already scheduled. Number 6, your own star simply getting older. Stars do not need a dramatic final act to end a planet. They only need to get slightly brighter year over year, and ours is already doing exactly that. As the sun's output climbs, water vapor in Earth's atmosphere becomes a bigger problem than it sounds. Water vapor is itself a greenhouse gas, so a warmer ocean means more evaporation, which means more trapped heat, which means a warmer ocean still. Once that cycle takes hold, it does not reverse itself. Current modeling puts the loss of the world's oceans, boiled away by exactly this kind of runaway evaporation, at somewhere between 1 billion and 1.5 billion years from now. You do not have to wait for the oceans to fully vanish for the news to turn bad. By roughly 2.8 billion years from now, models put the Earth's surface temperature at around 149 degrees Celsius, even at the poles. At that point, whatever is left of life on this planet is finished. The dramatic ending, the one you are probably picturing, comes much later and is, honestly, the least certain part of the whole story. Somewhere around 7.5 billion years from now, the sun will swell into a red giant large enough that some models have it swallowing Earth whole. Other, more recent models, built on updated calculations of how a dying star's gravity actually interacts with a planet's survive as a scorched, airless rock instead of being consumed outright. Astronomers genuinely do not agree yet on which fate we get. Either way, nobody involved is arguing that Earth stays somewhere you would want to be. Here is the strange part. Of everything on this list, the sun is the only threat that has given us advance notice measured in the billions of years. That makes it, by a wide margin, the single most polite way a star has ever devised to end a planet. Number 5, a solar storm bigger than anything on record. Object to get hurt by a star. Our own sun has already demonstrated what a genuinely bad day looks like twice, and both times are on the historical record. The first case is well documented because it happened during the age of the telegraph. On the 1st and 2nd of September 1859, a geomagnetic storm now known as the Carrington event slammed into Earth's magnetic field. Telegraph systems across Europe and North America failed outright, and in some cases their operators were shocked by the current surging through the equipment. In one especially strange, well-documented exchange, telegraph operators working the line between Boston and Portland, Maine, disconnected their own batteries entirely and kept transmitting messages to each other anyway, for roughly 2 hours, powered by nothing but the current the storm itself was inducing in the wires. In 1859, the only infrastructure vulnerable to a solar storm was a length of copper wire. Today it is the power grid, GPS, and every satellite currently in orbit. That is a difference in what is exposed, not a difference in how big these storms can get. The second case is the one that should worry you more, and we only found out about it in 2012. Researchers examining the growth rings of Japanese cedar trees discovered a sudden sharp spike in radioactive carbon dating to the year 774 or 775. The spike represented roughly a 1.2% jump in carbon-14 concentration, the kind of signature produced by an enormous burst of radiation striking the atmosphere all at once. The leading explanation is a solar particle event thrown off by, possibly, the single strongest solar flare our star has ever produced. Based on that carbon signature, the 774 event is estimated at 10 or more times the size of the Carrington storm, and roughly 20 times the sun's normal range of activity, more than 1,000 years before anyone had a telegraph wire around to fry. Our star has already shown us its ceiling. We only found the evidence in the last decade and a half, sitting quietly inside tree trunks the entire time, rings deep, waiting. Number 4, a supernova close enough to matter. A star does not have to be aimed at you to hurt you, it only has to die somewhere nearby. When a massive star runs out of fuel and its core collapses, and gamma rays. According to NASA, for that radiation to actually damage Earth's ozone layer, the explosion has to occur less than 50 light-years away. Inside that range, the radiation would strip away enough ozone to let in a flood of the sun's own ultraviolet light, and the damage would not look like an explosion from Earth's surface at all. It would look at first like nothing. The visible flash would arrive, fade, and only then would the slower damage begin. Elevated radiation, a thinning shield against ultraviolet light, a marine food chain collapsing from its most exposed layer upward. This is not purely hypothetical. Astronomers have found physical evidence of a supernova that exploded roughly 2.5 million years ago at a distance of about 300 light-years, comfortably outside the 50 light-year kill zone, but close enough to confirm that these events genuinely do happen in our galactic backyard, on a schedule of millions of years, not billions. The reassuring news is specific and checkable. Every star in our current galactic neighborhood capable of going supernova sits well outside that 50 light-year danger radius. Nothing nearby is loaded and pointed at us. The mildly less reassuring news is that a galactic neighborhood is not a fixed address. Stars drift, orbits shift, and the distances involved are already changing on exactly the kind of timescale this entire episode has been discussing. Number 3. A rogue star passing through your OORT cloud. Space is mostly empty, which is exactly why this entry is so unsettling. A star does not need to collide with the solar system to disrupt it. It only needs to pass close enough to disturb the loose, distant shell of comets surrounding it, a boundary called the Oort cloud, which sits so far out that light itself takes the better part of a year to cross it. In 2015, astronomer Eric Mamajik and his collaborators, publishing in the Astrophysical Journal, established that a small, dim binary star system now called Scalz's star passed within roughly 0.8 light-years of the Sun. That happened about 70,000 years ago, well within the span of modern humans existing as a species. Running 10,000 simulated versions of the star's likely trajectory, the team found that in 98% of them, it passed directly through the outer Oort cloud. The star itself was not flagged as anything unusual until 2013, when astronomer Ralph Dieter Scalz noticed it. Nobody knew it had already brushed past us until someone ran the numbers backward, tens of thousands of years after the fact. Comets that make up the Oort cloud do not normally bother anyone. They sit in a slow, cold, stable orbit trillions of kilometers out, essentially inert. A close stellar flyby is one of the only known ways to meaningfully disturb that stability at scale, and once a chunk of that material starts falling toward the inner solar system, it stays in motion for a very long time before anyone down here would notice a thing. It only needs to nudge a fraction of that distant shell out of its stable orbit and send some of the debris falling inward, on a delay measured in thousands of years. In a very real sense, we are still waiting to see the full bill for a bar tab that was run up 70,000 years ago. Number 2. A magnetar anywhere in the neighborhood. If a supernova is a star dying loudly, a magnetar is sometimes what it leaves behind, and the leftover does not calm down afterward. Its existence as a massive star running out of fuel. Only a small fraction of those collapsed cores end up with a magnetic field this extreme, which is part of why magnetars are considered rare even by neutron star standards. A magnetar is the collapsed core of a dead star. City-sized, unbelievably dense, wrapped in the strongest magnetic fields known to exist anywhere in the universe. Based on how fields at that strength interact with ordinary matter, a magnetar's magnetic field would be lethal at a distance of about 1,000 kilometers, and not because of heat or radiation in the way you are probably picturing. A field that strong distorts the electron clouds of the atoms in your body directly. You would not simply be killed by a magnetar at that range. You would be taken apart at the level of chemistry itself, which is a genuinely strange way to go, and arguably the single most bizarre entry on this entire list. You do not have to speculate about what these objects can do from a distance, because one of them has already shown us. On December 27, 2004, a magnetar called SGR 180620 released a giant flare so powerful that in 1/10 of a second, put out more energy than the sun releases in 100 for roughly 42,000 years before it finally reached Earth. When it arrived, it struck our ionosphere hard enough to measurably, if briefly, expand it. That is the documented effect of a magnetar flare from a source 42,000 light-years away, which in galactic terms is practically next door and, for all practical human purposes, nowhere near us at all. Now run the math the other direction. A blast that size happening within roughly 10 light-years of Earth would be enough on its own to strip the ozone layer and plausibly trigger a mass extinction. The magnetars we have actually located and studied, including one sitting about 20,000 light-years away in the constellation Aquila, are nowhere near that range. This is one of exactly 2 entries on this list where the honest answer to how worried you should be is simple: not very. But only because of where the dice happen to land, not because the mechanism itself is gentle. Number 1, a gamma ray burst with 0 warning. Everything else on this list gives you something. The sun gives you a billion years of notice. A supernova gives you a 50 light-year buffer. A magnetar at least announces itself as strange and exceedingly rare. A gamma ray burst gives you the light itself, arriving at the speed of light and nothing whatsoever before it. Gamma ray burst is the most energetic kind of explosion known to occur anywhere in the universe, typically produced by the collapse of a massive star or the merger of 2 dense stellar remnants, and for a few seconds it can outshine an entire galaxy. If one occurred in our own galaxy and happened to be aimed our way, and aim matters enormously here, since the energy travels out in a narrow beam rather than in every direction at once, the damage would not arrive as heat. It would arrive as radiation capable of tearing apart the nitrogen and oxygen in the upper atmosphere and stripping away the ozone layer that currently blocks the worst of the sun's own ultraviolet light. In 2004, a team of researchers, Melot, Lieberman, Laird, Martin, Medvedev, Thomas, Canizzo, Gerals, and Jackman, proposed that this may have already happened to us once. Their published position, stated carefully, is that the late Ordovician mass extinction, occurring roughly 440 million years ago, may be at least partly the result of a GRB. That extinction event is dated by other researchers to approximately 445 million years ago, and is estimated to have eliminated somewhere between 49 and 60% of marine genera, and nearly 85% of marine species alive at the time, making it the second largest extinction event in the planet's history, behind only the one that ended the Permian period. Nobody involved is claiming this is settled. The researchers proposing it use exactly the hedged, careful language you would expect from scientists arguing about a single afternoon that happened 440 million years ago, which is the kind of argument that can, in principle, run forever, since none of the parties involved are available to settle it. What earns this the final self? Unlike everything above it, a gamma ray burst gives a planet no lead time whatsoever. The first sign would be the thing that ends you. Extinction by starlight, arriving faster than any siren could ever warn you, is as close as this list gets to true cosmic bad luck. Here is what connects all 6 of these. None of them requires malice, because stars do not have any. The sun is not trying to boil away our oceans a billion years from now. It is simply getting older the way every star does. SGR 180620 was not just happened to put Earth in the general neighborhood, 42,000 years too late for it to matter to anyone standing here today. Skulls' star was not passing through our solar system to disturb anything on purpose. It was just 2 dim, faint stars falling through space on a path that happened to graze ours, 70,000 years before anyone alive could have known. The pattern here is scale, not intention. Every mechanism on this list is completely indifferent to the planet it might eventually end. The star does not know Earth exists anymore. The physics simply does what the physics does, and every so often, on a timescale too long for a single human mind to really hold on to, a planet happens to be standing where the numbers land. Every one of these 6 mechanisms is real. None of them is a schedule for next Tuesday. The difference between a documented physical process and an actual prediction is the entire distance between science and panic, and this list lives firmly on the science side of that line. That is either the least comforting thought in this entire episode, or available. Nothing on this list is coming for us specifically. We are not owed a catastrophe, and we have not been spared one either. We are simply standing for the moment, somewhere the numbers have not caught up with yet. Here is a question worth sitting with. If you could actually find out today which of these 6 was eventually coming for this solar system, would you really want to know? Leave your answer in the comments. The next episode in this series stays much closer to home. The environments already here on Earth that are actively hostile to human biology, no star required, and the specific, occasionally absurd ways the human body fails the moment it ends up somewhere it was never built to survive.